Okay, for 14.1, right, generally I don't have much comments about it, okay, except that I think, although it's a bit too late for me to say now, okay, I think some of you have some issues with the notations. I hope that up till now, that we are already going to chapter 17, you have clarified about the notations, because I noticed that some of you write things like dy over dx, then after that, the expression inside like that. Okay, I hope that I would have circled it inside your homework if I have seen it. Okay, 14.2, also not much of an issue when it comes to chain rule, alright? But is there any problems for 14.2? No? Okay, 14.3 also regarding product rule, not much of an issue. I do notice that some of you don't have the habit of simplifying it, okay? At this point as homework, okay, I will accept the answer. However, in exam, please take note of the form that you are required to simplify to. And please, at best, try to simplify as much as possible, okay?
Yeah.
Yes.
Is it wrong to put d over dx?
It is not wrong, okay? It is okay if you want to put d over dx and then the expression, okay? But it is wrong if you put dy over dx.
Then how about d dx equals to?
No, this doesn't make sense. Why are you differentiating? This doesn't make sense. You need to tell me why you're differentiating with respect to x. So it's only this, and this is also not acceptable.
So after the bracket,
Yeah, then after that from here, the equals to then your derivative lah. Okay? Then, what's it saying now? 14.3 product rule. It's not much of an issue, right? Oh, okay, then of course 14.3, as I was saying, simplifying your answer. Right, when you do product rule or even 14.4 quotient rule, right? Okay. I mean, to be very honest, okay, let's look at exam-wise kind of base setting, right? Okay, they ask you to maybe differentiate something. Maybe some 3x minus 1 over 2x squared plus 4. Okay, differentiate something like that. Then after that, you go on to differentiate this using your quotient rule. So you immediately apply your quotient rule, and then after you get some answer. Right, but the thing is that this question, say for example, is 3 marks. Does it make sense that you just leave your answer like that? No, right? Okay, surely cannot be just simply applying quotient rule, you never simplify anything and then we give you 3 marks straight, correct or not? Okay, so please make sure that have some sensing, okay? 3 marks surely they will expect you to do some simplification, okay? Why I'm stating this out is because, I mean, you know, school-based exam, okay, we would actually test simple stuff like this, differentiating an expression, but of course when it comes to O levels, they will not ask you to simply differentiate this one already. There will be many more layers to it, okay? Which is what we look at in chapter 15 and 16 now, right? You understand what I'm saying? Okay, then after that, 14.4 also quotient rule. It's about whether you know how to apply. Some of you may have some careless mistakes. Okay, then after that, 15.1. Okay, 15.1, as I was marking, I don't have any much issues about it as well, okay? Because I think I went through certain questions before you submitted it already. But are there any problems regarding the homework? No? Okay, so if no problems, please submit your corrections, or rather please do your corrections. Okay, I will just return it to you, you go and do your revision. Submit your corrections as you file it inside. So just do your corrections, file it inside your file. At the end of the term, when I collect your file for file check, okay, I will do the marking. Don't have corrections, you also still file it. So I don't want you to collect your corrections this time round, right? You just file it inside your file. I will mark it when I collect the files, right? File collection or rather file submission to the school leaders will be end of this term, okay? So I believe it should be across all your subjects. So please make sure that you are consistently filing. I will be giving you your content page with you, right? Except for no need to file. Or even more you need to file. Yes, do corrections, file it inside your file. Okay? Can? Understand? Any questions? No, huh? Okay, I know that calling is a chore, but it is necessary. Okay, you need to organize your thoughts. Done. Okay, we will continue with chapter 17. Oh, okay, sorry, one more thing. Your A-Maths common test on week 8, right? I just got informed that there is a photo shoot for your class having a photo shoot on the first period of that day. Okay, so there's a photo shoot on that day, so I will put the test itself onto the second period because remember, even week Thursday we got 2 periods, right? Okay, the first period it is being interrupted by the photo shoot, so we will have the test on the second period. Okay, so after you all go for a photo shoot, everything ready, come back, then we start our lesson. Okay, then second period we will do our test. Understand? Okay. What? Do math, photo shoot. You can go and take photo in your math textbook lah. Yeah, 402 right? Yeah. You all can do that. Inspiration. So
all become math student.
does this spark joy? Science. Does this spark joy? Doesn't, is it? Then you want to invite Marie Kondo to come and maybe stab your books, clear away your books. You must thank the books. Yeah. You want to kneel down? Okay, let's do chapter 17. Okay, so earlier in the previous chapters, we have been looking at differentiation for all the algebraic expression. Okay, we have understood chain rule, product rule, and quotient rule. So all these rules will still apply, okay, regardless of what kind of things you're going to differentiate. But now in this chapter 17, we're going to look at how do we differentiate certain functions, special functions like your trigonometry, your logarithms, and also your exponential. Okay, so first we look at differentiating the term sin x, okay, and then also how do we differentiate cosine x. So when differentiating sin x itself, it is defined that it will give you cosine x. Okay, so differentiate sin x, it will give you cosine x. If you differentiate cosine x, it will actually give you negative sin x. Right? It is being defined that way at this point. Okay, you will just have to accept it. Right? I can do a small proof, alright, to define for you why is it that if I were to differentiate tangent x, okay, it will actually give you secant square x. Okay, so the reason for that it is because if I let y equals to tangent x, and I know that tangent x is actually sine over cosine. Okay, so this is a fraction. We can use our quotient rule. So differentiating your tangent x by using quotient rule, we keep the bottom, differentiate the top, and then minus away, keep the top, differentiate the bottom, right? And then after that, the bottom we square it. Right? That's how we apply our quotient rule. Okay, so this will be cosine square x plus sine square x, and then cosine square x. So this will be equals to 1 on the numerator, cosine square x, and this is none other than secant square x. Okay, so this is just a very simple proof to show you why is it that tangent x, when differentiating, we will get secant square x. Okay, but of course you don't need to go through this proof. You just need to know how to apply, okay, the derivatives. That's all. Alright. to differentiate these three expressions here. So let's just assume that all of it are y, we let it be y. Okay. So to differentiate part A, alright, it will be the same as how we differentiate our usual algebra. So differentiate x is 1 minus the way 2. So sine itself is differentiated to become cosine x. Okay, so sine x changes to cosine x. Alright. So therefore the answer will just be 1 minus 2 cosine x. That's why I put marker turning back. Okay. Then after that, for part B, if I want to differentiate x plus 1 times tangent x, we also apply our product rule. So keep the left, differentiate the right, that will be secant square x. And then plus, keep the right, differentiate the left, that will be 1. Okay? And then simplifying your answers. In this case, nothing much to simplify. Yeah.
You just put d dx bracket the aside.
Can.
Simplify.
But I don't want to write so much. Yes.
Simplify putting everything into one fraction.
Put it into one fraction. This one into one fraction. What fraction is that? Oh, this one 1 over cosine square. No need. Okay, you do not need to unpack this secant square x into 1 over cosine square, and this one change to sine over cosine. That one no need. Okay, just keep to this simple already. Right? And then for part C, we will use our quotient rule. Okay, so keep the bottom, differentiate the top, negative sine x. Plus keep the top, differentiate the bottom. Yeah, I think it's gradually changing. Okay, any questions? Right, so you see that when we do differentiation of trigo functions at this point, that trigo function itself, it will be changed to another one. Right? So do take note of that. Yes, so if I differentiated tangent x, it became secant square x. When I differentiate my sine x, it becomes a cosine x. Alright? Any questions? Yeah, sounds good. Oh, sorry. Minus. My apologies.
Minus x sine.
Yeah, so then after that, this one then you can simplify negative sine x plus cosine x over x squared. By the way, I do notice that some of you have this kind of algebraic error. Negative on the numerator, and then you want to take it out to make it for the entire fraction. Please make sure that the sign is being changed inside as well. Okay? Because it's a factorization. Right? Any questions? If not, I want you to practice. Okay? Exercise 17.1. Question 1C, D, 2A, C, D. Okay, I want you to do these questions now inside your exercise book. Bracket this one. Or this one.
I need the answer to like Tx sin x here to like get sin x or get an x.
What do you think?
Like if like the as sin whole thing x plus the sin x or something.
Sorry, repeat. What can it be? Sorry, what can it be interpreted as?
Sin the whole thing after that.
The whole thing after that.
Yeah, you can interpret
If you want it that way, then you must be brackets. But in this case, you cannot. Definitely cannot interpret it that way. It will definitely be sin x itself, then separated out plus cosine x. It is only if you want it to be whole thing, then of course you put brackets. Otherwise, by convention, definitely it's brackets.